An Elementary Introduction to the Wolfram Language. Lesson 6. Making Tables.
In this lesson, we will be learning about one of Mathematica's most powerful and important functions, table. This function is used in almost every substantial Mathematica program because of its usefulness. To sum table up in a sentence, it is pretty much a way to generate many different types of lists easily. Here's table in action. Here I'll type table of the string hello, 9, and then I'll hit Shift Enter. The above code generated a list of 9 hellos. The table function always has two parts to it, the expression and the iterator. The expression is the part that determines the output, and the iterator, put simply, chooses how many times the table goes through the expression. Here I'll take the code from before. Now I'll comment in where the expression and the iterator are. As you can see, the hello is the expression and the 9 is the iterator. Now let's go into more depth regarding the iterator. In the above code, the iterators have been just one number that specifies how many times the expression is repeated. The iterator can do so many other things though. Here I will make the iterator slightly different. So here I'll do table of the string hello, comma the list n, 9, and I'll hit Shift Enter. The above code just produced the exact same output as the prior tables, but this time there is a little light blue n in the code. That n is not just there for decoration, and when it is also put within the expression, it makes the table a little more interesting. So here I'll do table of n, comma the list n, 9, hit Shift Enter, and as you can see I get the numbers ranging from 1 to 9. The cool part about this is that unlike range, table doesn't just generate these simple types of lists. The n can be manipulated in many different ways. So here I'll do table of 2 to the n, comma the list of n, 9. Hit Shift Enter, and as you can see I get the first 9 powers of 2. Just playing around with the n in the expression allows for some interesting lists to be produced. Now let's get back to talking about the iterator for a little bit. In the above uses of table, the n always starts at 1. If you change the iterator a little bit though, you can make it go from 3 to 9. So here I'll do table of n, comma, the list of n, 3, 9, I'll hit Shift Enter, and as you can see I get the numbers ranging from 3 to 9. And if you add one more number to the iterator, you can change the step size too. Here I'll do table of n, comma, the list of n, 3, 9, 2, hit Shift Enter, and as you can see I get the numbers ranging from 3 to 9 in steps of 2. One last thing about the iterator is that the n doesn't have to be an n. It can be any letter or combination of letters that is not already a built-in function. Here I'll do table of happy, comma the list of happy, 1, 9. I'll hit Shift Enter and I get the numbers ranging from 1 to 9. Here I'll do table of zebra, comma the list of zebra, 5, 30. Hit Shift Enter and I'll get the list of the numbers ranging from 5 to 30. Now let's go learn about the expression in table. You've seen the expression be a string, a number, and a variable, but it can be so much more. For example, you can make the expression be a list, so that the final output is a list of lists. So here I'll do table of the list of n, 2n, comma the list of n, 15. I'll hit Shift Enter, and as you can see, the output is a list of lists, in which the second element of each list is double the value of the first. You can also make the expression something that is entirely different. So here I'll make a pie chart of the list of 1, 1, 1, 2, hit Shift Enter, and I get a pie chart. Then I'll wrap that pie chart in table, add a 3 at the end, hit Shift Enter, and as you can see I get 3 pie charts. Here we will make a table of columns of range. So I'll type range of n, then I'll wrap that in column, then I'll wrap that in table and add at the end a list of n, 10. Hit Shift Enter, and as you can see, I got a table of columns of range. Here, we will make a table of tables. So I'll type table of 1, 10, hit Shift Enter, and I get a list of 10 ones. I'll then wrap that table in table, and add a list of n, 10 at the end. I'll then change the original 10 to an n, and then I'll hit Shift Enter. As you can see, I get a list of 10 lists of ones with lengths ranging from 1 to 10. The expression of table is in fact another table. And if you want to see those lists plotted, you just add pie chart to the outer table. So here I'll take the code from above, and then I'll wrap the inner table in pie chart. I'll then hit Shift Enter and I get a list of the pie charts of the lists of 1s with lengths ranging from 1 to 10. I'll then wrap that code in row so the pie charts are easier to see. You can also use table to generate a list of points on almost any type of mathematical function and plot them. Here's how you can use table to make a parabola. So here I'll type table of x minus x squared, comma the list of x, 0, 1, 0.02. Hit Shift Enter and I get a list of points. I'll then wrap that in list plot, and as you can see, I get a parabola. Here I will do the same thing and make an asymptote. So here I'll type table of x over x plus 1, comma the list of x, 0, 10, 0.1. Hit Shift Enter and I get a list of the points. I then wrap that in list plot, and as you can see, I get an asymptote. The last important thing that you should know about table is that it computes every entry separately. So here I'll type table of random integer of 10, 10, and as you can see, every entry is a random integer. I'll then run it a few more times. As you can see, each random integer is completely independent of the others. Also, you can get the same exact type of list using just random integer. So here I'll type random integer of 10, 10, hit Shift Enter, and I get a list of 10 random integers. And now we can make a list line plot of random integers where the nth integer is between 0 and n. So here I'll type table of random integer of n, the list of n, 10, and then I'll hit Shift Enter, and I get a list of 10 random integers. I'll then wrap that all in list line plot and hit Shift Enter. I'll then run it a few more times, and as you can see, each list line plot is completely different, but just as cool as the others. Thank you for watching, and I will see you in the next lesson.